It's been such a treat to be here, and for a whole number of reasons, but I direct the Understanding Science for Teaching project at West Ed, and the work that I'm about to share has been a really fun collaboration between sort of a research and development team over a decade. So if you think of an R&D organization, West Ed is a not-for-profit organization, and we partnered with a variety of folks, but in particular, Dr. Joe Keller, one of the research associates, colleagues from UC Berkeley and many other places, in a fun way to have conversations about how can you develop teacher PCK. So I come from more the development side, first as a classroom teacher, and looking across at the U.S. and saying, look across the U.S. and say, we have a really profound problem, and that many teachers find themselves in the classroom without the content knowledge, pedagogical knowledge, expertise that they need. How can we tackle this monumental challenge? And being a classroom teacher, I said I want to do it in a way that is respectful of the profession and also cognitively demanding and whatnot. So we kind of work from both sides and have had some very interesting conversations both from the research end and the development end. So I'll start off by just talking about what our approach is to PCK and to developing PCK, but knowing that that's our focus, our purpose, then you can see how that shapes the kind of research we've done and what kind of results we think we found and what we don't yet know. So one thing that's been fun is that Lee Schulman is my grandfather, in the figurative sense. Yes, no, and then my boss was a graduate student of his, and so we sort of live in his neighborhood. I started out early on just with that was the those were sort of the ways of thinking about pedagogical content knowledge, and I remember meeting Jan and John in 2004 and them asking me something about, so what is your conception of PCK? And I said, Schulman's, of course, what else is there? But over time, as we've been looking at and informing our thinking about PCK, we've moved from, we still are very grounded in Schulman's thinking about the teacher's knowledge of learners and teacher's knowledge of teaching. But on the left-hand side is sort of our more current conception of PCK as we vote for this summit, in fact. And you'll see in here, if we think about PCK comprising the intersection of knowledge about teaching and content, that is the knowledge of teaching a topic-specific content. So we actually wrote this before we came. You can see our topic-specific nature and the fact that we think of it being enactment. So it refers to teachers' abilities to organize instruction around a coherent set of interrelated concepts, to anticipate, elicit, interpret, and address particular challenges, and more about the sequencing and representation. So if that is what's behind some of our thinking, let me just take a minute or two to tell you about the curricular materials. So we looked at how can we not develop materials for student learning, but rather, regardless of the curriculum a teacher uses, look at an intervention for teachers that supports their understanding of the science itself, but does so in the context of teaching. So when we say a curriculum for teachers, this is what it looks like when you finally put your ideas down after 10 years and commit them to a curriculum. So this is like the actual teacher book that would have the things that we're learning in it, and I would call it an educative curriculum. And that we try to put in what's known about best practices, what's known about misconceptions research, and whatnot into ways in which teachers work together to learn the science, think about the kids' ideas, improve their teaching, and whatnot. So how do we do that? The actual Making Sense of Science courses have two components. There's a core course, which is a 30-hour intervention. Typically, it's used as a 5-day, although we have pre-service folks who are using pieces and whatnot as parts of the courses. They're designed intentionally for adult learners, led by facilitators. In the core course, I think it's interesting to note if you're bringing together the content and the pedagogy, how do we do that? We start out with science investigations, where teachers actually engage with the science as adults, not doing kid activities, but doing activities where they're actually pressed to find the holes in their thinking, the misconceptions in their thinking, the boundaries of their thinking. But they do that first in collaborative small group work with peers, where we have them use evidence and do investigations, and we try to give them a profound learning experience in the ways that they see are powerful to their own learning. And then we ask them to look at teaching investigations. So we actually began the teaching investigations. So Lee Schulman's wife was a colleague of mine at West Ed, and she was doing a lot in the case methods approach to learning. So if you think of any profession where there's complex decision making, medicine, law, whatnot. Teaching is one of those. So the kinds of cases of practice that you'll see in the materials that we have, we try to develop pedagogical content dilemma cases. So we want them to be examples of strong teaching, so they're exemplars in some way, but science is always tricky, and so we look for the tricky spots. One more quick thing. Then we also know that learning is supported by literacy, and then we have teachers at the end say what are the connections to the classroom. There's a whole second component that I'm not going to get into because our research didn't actually involve any teachers who did both parts, but teachers can go and look at student work in their own classroom. So what do we know about PCK based on our research? So over the past 12 years, with Jonah's key research partner, we've done a series of large-scale, multi-state studies. Some have been quasi-experimental, others have randomized controlled experiments. We've had an N of 9, an N of several hundred, and we've looked in different ways. And our one result we found in this is that if we're really trying to benefit student achievement on the left-hand side, and we're looking at developing an intervention for teachers on the right-hand side, and you'll see that we developed this or modified this from Horizon Research, so nods to you all. But if our intervention is to develop teacher content knowledge and pedagogical content knowledge to bring about change in the classroom to then impact student achievement, can we look at that cascade of influences? So I'll share some of the results and try to help you understand the context in which they came to be. So this is data from a study where we had teachers go through an intervention, as I just described, with science investigations and teaching investigations. Oh, I should go back 1 second. What we found is that that this intervention actually deepened teachers' content knowledge. We found effect sizes for gains in teacher content knowledge at a phenomenal effect size of 2, which is just pretty unheard of. So what teachers knew after 30 hours of intervention was really significantly different than at the beginning. And we also noted more sophisticated pedagogical content knowledge. We documented changes in teachers' classroom practice, and we did find, indeed, correlations and evidence of increases in student achievement, and then through hierarchical linear modeling, the correlation between the intervention and the student achievement. The student achievement gains were in the 0.4 effect size range, and true for all groups. So girls, boys, low achievers, high achievers, with preferential benefit to English language learners and low achieving students. So if all teachers benefit, then the question is, what do we notice about teachers' gain in pedagogical content knowledge? So I put a circle around the effect size over here, and I'll try to parse this out. We ran a study with several hundred teachers across the United States in 6 different states and looked at those teachers and their students. But we divided the teachers into interventions that differed by a particular feature. So some teachers got content immersion, which means that they got the science portion of this course, so they learned science in a really rich way. So that's the bottom line, the content immersion teachers. And then instead of doing teaching cases of practice, we had them be metacognitive and reflective on their learning experience. So we didn't provide any artifacts from the classroom or any source of PCK. And in the teaching cases, rather than doing the metacognitive reflection, we have the teachers read teaching cases. So then we looked at these teachers' pedagogical content knowledge, and we found that the lower right here, the 0.044, would be the effect size change for teachers who had content immersion. But you see at the p-value of 0.08. Not the correlation, but on the effect size for teaching cases, an effect size of 0.87. And so what we can say from that is that whilst content knowledge is necessary, it's not alone sufficient for developing PCK. Because the teachers in both groups, the content immersion and the teaching cases, both had effect sizes of close to 2 in their own gains of content knowledge. So both groups, teachers learned a lot, but the development of PCK was really quite different. So one other thing that we know is that teachers' PCK with this intervention became more complex, more detailed, coherent, and integrated. And that what we mean by that are, here's some examples. Teachers had a greater clarity about what students should know about a given topic and how to organize it. So we look at how they plan, how they can anticipate kids, what makes their learning difficult, how they would interpret student work, and also what links they could make between a particular kid challenge and what to do about it. So here are some of the kind of qualitative examples that we have that we would work from with an interview. So we used a structured interview protocol. And on the left-hand side, we asked teachers about circuits. We said, what do you think would be hard for elementary students with learning about circuits? So initially a teacher might say, I think the concept of short circuits is hard. It's hard for me. That's just sort of a guess. So sort of that a little more like a blank slate, or I only have my own experience to go from. But after 24 to 30 hours of intervention, then a teacher could say something like this. In this example, some of the things that are not really explicitly taught in the kit, like resistance, the idea of a quantity of electricity that comes out when out of a battery, the difference between voltage and amperage, and the architecture of the light bulb. If you don't get that, it's pretty hard to make a conceptual leap about a complete path. So you see some pretty stark comparisons. The first we rated a level 2 on a rubric, and the other a level 4. So in the interview, sometimes we, like others in the room, would give some explicit sort of small prompt for the thinking. We would first ask teachers what they thought would be the answer to this problem, what would happen if you unscrew the middle light bulb, to see what their content knowledge was. And then we would give them a student response that represented a classic misconception. So kids often think if you unscrew the middle light bulb, the other light bulb will get brighter. Not true. So we would ask teachers, if you had a student in your class that had this response, what might you do? So we looked at this kind of comment both quantitatively and qualitatively, but in one of our RCTs, where we had teachers in the teaching cases group and the content immersion, we asked the prompt, what might the teacher do next to move the student towards further understanding of electric circuits? And Joan and I were having a conversation earlier today. We were getting ready for the presentation, where we were saying there are many different ways that we could look at the data, and here it almost looks like what we're showing is that teachers are changing their orientation. So let me talk you through the data, and you can see what I mean. So we coded teachers' responses, and what the numbers that you see here are percents. So 19% of the teachers gave an answer that was only explaining. I would tell them what to do if they were in the teaching cases. But if you follow that line down from 19% to 10 to 29 to 47, what happens going down that line is a teacher might say, I'd have them do a hands-on activity, that's 10%, or 29%, I would have them do a hands-on activity, and they would explicitly then describe a sense-making activity to go with it. Or in the highest group, most teachers, 47%, gave at least 2 different sense-making activities. So that was for the teaching cases group, but if you look at the content immersion group, had the same science learning experience, what they would describe that they would do with the student was quite different. So of those teachers, you see that 30% would be in the explain mode, and only 22% would be in the at least 2 sense-making. And then there's a control group on the side for comparison, and you can see that the control group and the content immersion are very similar. How am I doing? Terrible?
Yeah, you're over.
I'm over. All right, then I'm there. Carry on. So 2 other results that I won't talk you through them, which is that we found, again, a qualitative, more sophisticated response to how you go about helping a student. And then we looked a year later, and we said, so we looked at this teacher's response, and then a year later we went to the teacher and asked a similar question, and this teacher actually described what the teacher did in their classroom, which is odd. I had series circuits, and then I had a group of 4 kids, and so they could describe their enactment, which showed that their rubric level went from a 2 to a 3 to a 4 over time. The prompt for us on this panel was to say, what do we know, and what do we not yet know, and if we knew what we were doing, it wouldn't be called research. I think that the questions that I have on the right, maybe the group this morning did a better job of saying what the potential avenues for research might be. These are more particular to our group, but we're really looking at what is the mechanism and what is the interplay between features. And we took on a bold development project and a bold research project and made some headway in both. So